I'm going to talk to you about Objective-C and macOS. Because I assume you have heard of macOS. And I always say macOS, it would sure be nice to support it. Sadly, it's not that easy. And this talk is about that and the story of working with macOS. The year is 1981, and we're at the Programming Technology Center in Stratford, Connecticut. And a man is sitting in front of a, for its time, relatively new computer, and he just saw the future. Smalltalk. And the name of the man, he was called Brad Cox. And to understand why he was so obsessed with Smalltalk, you have to understand that at the time, the field of software engineering was in full-on crisis mode. Software engineering had recently graduated from a niche academic indulgence into a proper profession, something that paid people's wages, that required teams, managers, that funded companies, right? And computers were getting more powerful by the day. But software often, failed to capture that new power. And, projects also run over budget, over time, were inefficient, difficult to maintain, low quality, and, all that what we would now call normal, the people called a crisis at the time. And understandably, they tried to come up with solutions for that. And Brad Cox was exactly one such person. He was convinced that the key to that was actually making code more reusable, and that is actually where Smalltalk comes in. Because Smalltalk, invented or sort of released in the 70s, came out of Xerox PARC. The idea was that your program, object-oriented, was made up of objects, and each object would send messages to other objects. And then those objects could react to those messages and modify their state, and all that was happening at runtime. There's no code examples of Smalltalk because it was after the invention of lowercase, but before the invention of sane syntax, so I will spare you that. That was great for modular code because you could just swap out objects. So he liked that, but Smalltalk was slow, way too slow. Way too slow for what he wanted to do with it, which was building network infrastructure, right? Telephones, all that. It also lacked compatibility with C, and that just made it a straight-up no-go. Now, he began working on a preprocessor to C, and that was called OOPC. It's a placeholder slide because for the life of me, I could not find a logo for it, so deal with it. I wanted to highlight one other thing that I found while researching that, though, and that is for the first, sort of the release paper of that preprocessor where he announced it, there's this one section, discussion, and if we zoom into that, there's this wonderfully disturbing line. Here you go. Executable electronic mail. People were using Objective-C to build executable electronic mail, and that, I don't know, Objective-C, horrible on its own. In my mail, executing on its own, unsure. Unsure, very unsure. But that got me thinking, there might be a future that we have very narrowly avoided. Objective-C, the language of the web, running your websites. Anyway, just a small side note. So Objective-C consists of a runtime. That's the central part of your code, right? That is what knows about your classes, what knows about your objects, that handles all the messages, forwards them between each other. And then, as I said, you have classes, you have objects. If you have worked with Java or any other object-oriented programming languages, that's the same thing, essentially. Objects send and receive messages, and all that is very dynamic. So you also have dynamic typing, all that. Everything is sort of resolved at runtime. Cool. So with that language in hand, Brad Cox and a colleague of his, Tom Love, they started a company to focus on this language, to sell it to people, to make it usable. And sadly, they passed up on the opportunity to name it that. Instead, they called it Productivity Products International. Worse, if you ask me. So, meanwhile, on the other side of Palo Alto, in a small Silicon Valley company, the company was in big turmoil. Because Apple had just launched its latest product, the Apple Lisa, and it was a massive flop. It was technically impressive. They didn't sell any of it. And it was such a flop that Apple actually tried to erase this from history, going so far as like in a stealthy nighttime operation, with armed guards, destroying them and burying them in Utah in a landfill. Understandably, Steve Jobs got into trouble for that. He was leading the project, and he was, essentially demoted after that. And soon after, he was sort of forced out. Sources aren't, quite sure on if he left on his own terms or if he was actually forced out. But he left Apple in 1985. And he didn't leave Apple to do nothing. He founded a company called Next. And essentially, Next was going to do what the Lisa wasn't. They were building their own workstation machine, right? Highly powerful, and with the software to accompany that. And exactly here's where Objective-C comes back in, because for this software, for their Next Step operating system, they licensed Objective-C to build that. And widely lauded. And then, a couple years later, after the company that was started by Cox and Love they run into financial troubles, and then Next just outright buys them, right? So, forward in time, this looks very different to what I just showed you, but it's built on the same fundamentals, right? So macOS of today, it looks very different, but it's building on the same fundamentals that back in the day Next Step did. It's building on Objective-C. Objective-C powers all of it. And if you recall sort of to the beginning of the talk, macOS, sure would be nice to support it. We all want to build cool stuff for macOS, right? But we must use Objective-C, even though we don't want to. And now, you might say, so what? Apple uses Objective-C, how bad can that really be? And to understand why this is a problem, let's shift gears, let's talk about a different language that you might know. Forgot to insert the Rust logo, sorry. We're talking about Rust. Not sure if you've heard about it. It started as a side project of Gradient in 2006. By 2010, it was officially announced as a Mozilla-sponsored project. And while the Rust of 2010 looked much different than Rust of today, sort of there's a North Star that has guided the project sort of ever since its inception. And that's the internet. And to make sense of that, there's a great quote from Graydon, sort of in an early interview, where he said, basically, the internet nowadays is highly concurrent and highly security conscious. And that means the design trade-offs that traditionally have favored C and C++ for building applications, they've been shifting over time. We're not living in the 80s anymore, right? We're living sort of in the 21st century. The time has changed. The world now is incredibly interconnected. And, smartphones, they are our lives now. Fridges can buy stuff online with your credit card. And even my arm can talk to my phone, right? And sort of the Rust really is about, building a new foundation for this different age that we're living in right now. And it really does that by, looking back into the past, looking back at languages from the past, and then taking what was great about them and using that, and also looking at what wasn't so great at past languages, and not making the same mistakes, ideally. In another quote from Graydon, Rust is a language that mostly cribs from the past, nothing new. And of course, that's not 100% true, but that's the spirit. And so, what are these great features sort of that Rust touts, right? Like, especially now in the context of macOS. Because sort of we have a type system, right? Very proud of that. We have memory safety. You know, your program doesn't do use after free, doesn't have buffer overflows, all that. You have very strong control over the mutability of your variables. You know, it's immutable by default. You have to specify that. And you have no global garbage collector. You have very little runtime overhead. And you have strong compile time guarantees. Now, do you want to guess how many of those properties are shared with Objective-C? None, actually. So looking back into the past, Rust essentially sort of looked at Objective-C and was like, meh, you know, bad language. Let's forget it. Not quite, but like, you know. So Rust essentially is the opposite of Objective-C in almost every way, which brings us to sort of the fundamental of this problem. You know, I want to use Rust to build my apps, but on macOS I can only use Objective-C really, and that I don't like. Everything, you know, I want to emphasize is everything has to go through Objective-C. And on Rust, that looks like that. There's a crate called Objective-C. The crate exposes a macro called message send. And, you know, you give it sort of the target you want to send a message to, and you give it arguments that you want to send to that object. Now, this is not Objective-C. This is what Objective-C compiles down into, right? So in essence, this is even worse than writing Objective-C code. This is sort of, you know, very, very, very low level. We're just sending messages to a runtime. No quick code slide for fun. It's not fun. I want to emphasize that. So, yeah, we can play a little game. You want to guess that little line of code we had here? At which point could that crash? You know? And, or for what reasons would that crash? And I can just start, you know, type in the message name, crash, boom, program's gone. Type in the message argument, boom, crash, gone. You specified the wrong type as an argument, boom, panic, crash, exception, your program's gone. You specified the wrong return type, crash. The object is not ready to receive your message, also crash. It didn't expect that message at this point in time, crash. Or, you know, the object just didn't feel like it for whatever reason. You know, has a bad day today, whatever. So the typical workflow of working with that on macOS is, you know, you change your code and the app crashes. And you change it a bit more and it crashes. And you do that over and over and over again until it stops crashing. And then you merge the PR and it's good. So essentially, you know, all the Rust bindings to macOS, the only security guarantee you have is works on my machine, maybe. And of course, that's not great. It's not what sort of we stand for, not what I sort of want to put my name on. And so the question is, what can we, as you know, the Rust community, do to improve that? And I want to highlight two crates that have come out fairly recently. Awesome work. The first is called Objective-C 2, and it's basically a second take on Objective-C. Then there's iCrate. And the idea, essentially, of Objective-C 2 is that now your Objective-C calls actually are sound, and you know you can guarantee that. And then, as a second step with iCrate together, you have what sort of the author coined layered security, where you fundamentally Objective-C is incredibly unsafe, right? The whole point of it as a language is that you know nothing at compile time, right? You know nothing, and you will like it. But we can sort of layer layers of security and sort of assertions and type safety on top of that to make working with it actually quite nice. And then what iCrate really is code-generated bindings to all those macOS frameworks like, you know, AppKit, like WebKit, like the security framework, all those that you might want to use, and in idiomatic Rust. So actually, you can now look at Apple's documentation and replicate the code that they show you in your Rust code and not have to sort of know what it would compile down to in Objective-C. And then the second sort of thing I want to point out, and that's the one that's very exciting to me personally, also the one sort of where I'm working on a bit, Rust and Swift bindings. Because I don't know if you've sort of noticed that, probably not, because it was very much hidden away. During the last WWDC, the conference put on by Apple, they made an announcement, not on stage, not even sort of in their official blog, but like on the blog of the Swift language, that bindings between Swift and C++ are now stabilized, which means that we can now also have Rust to Swift bindings. And that makes me really excited, because that just means cutting out Objective-C completely out of the equation. And so hopefully, in a future point in time, all of that, what I just told you about doesn't matter at all, and we can actually bind to a language that's, proper to work with and not a nightmare. And with that, I think I talked really fast. We're done. Didn't introduce myself. My name is Jonas. The reason why I've been speaking to you is because I'm part of the Tauri working group, and they're really working on the horrible macOS stuff. I'm also DevRel at Cryptnebula, which means that I do stuff like that, but also, and I'm really grateful, a couple colleagues sitting in the first row, I just get to do cool Rust stuff every day and just do research and development, which is very awesome. If you want to follow along with that or any sort of other stuff, you can follow me on Twitter. It's Twitter. And yeah, thank you. If you have any questions, I've been told that it's better if we sort of gather in front. So if you have any questions, then please feel free to come up front. I also have limited edition stickers of the Tauri project. They will never be printed again. They are numbered. So grab them while they're still here. They will never exist again. And have a great lunch.